Math 1314, Tyler Junior College, Section 1.7, Linear and Absolute Value Inequalities. Compound inequalities, or. By the way, compound inequalities in this section come in two varieties, or inequalities and inequalities. So you know what the next video is going to be. Compound meaning more than one inequality, such as this one. Solve the compound inequality. 5x plus 1 is less than 11, or 3x minus 2 is greater than or equal to 10. I want to stress that the word or here doesn't mean that you have to choose one to solve. That just means your solutions only have to satisfy one or the other. So let's solve them and figure out what to do. Individually, these are easy and, dare I say, fairly trivial to solve. For 5x plus 1 is less than 11, just subtract 1 from both sides and get 5x is less than 10. Then divide both sides by 5 to get x is less than 2. Or, on the other one, add 2 to both sides to get 3x is less than or equal to 12, and then divide both sides by 3 to get x is less than or equal to 4. So our compound solution is x is less than 2 or x is less than or equal to 4. So we want all the numbers that satisfy either one of these. For example, is 1 a solution? Yes, 1 satisfies this inequality. That's all it needs. It also satisfies this one. Is 3 a solution? Well, 3 does not satisfy this inequality. 3 is not less than 2. But it does satisfy this one. To be a solution, you just have to satisfy one or the other. You might satisfy both. So yes, 3 would be a solution. Would 5 be a solution? Does 5 satisfy either one of these? No. 5 is not less than 2. 5 is not less than or equal to 4. To be a solution, you have to satisfy either one. Well, that's cute and all, but how do we actually get our solution? Well, let's think about this in terms of a number line. Because we're locating two numbers on a number line, we need to make sure they're in the correct order. Since 2 is less than 4, we'll put 2 to the left of 4. And let's think about each of these individual inequalities intervals on the number line. For x is less than 2, that would be all the numbers to the left of 2, with the parentheses on the 2. But for x is less than or equal to 4, that would be all the numbers to the left of 4, with a bracket on the 4. This should start looking familiar, especially if you watch the second video in the series. So where are the numbers that belong to the red or the blue, or possibly both? Wait a second. We want numbers that belong to one or the other, or possibly both. That is the very definition of union. So before we finish this problem, let's go ahead and summarize how to solve a compound inequality with or. To solve an or inequality, you only have to do two moves. Number one, solve each inequality, each individual inequality. And two, find the union of their solutions. Emphasis on the word union of their solutions. So we just have to join these together. And remember how union works. We can put both intervals on the same number line, and the union is everything that got shaded in. The first interval started at negative infinity, went all the way to 2 and then a parentheses. But the second interval also started at negative infinity, but went all the way to 4 with a bracket. So that's what it would look like if we unioned these two number lines together. So what's shaded in? From left to right, it starts at negative infinity, and it goes all the way to 4, but is 2 part of the union. To be part of the union, you only have to belong to one of the solutions, and 2 does belong to the second solution. So it is in the union, and the solution goes all the way to 4 with a bracket. So solving an OR inequality is pretty straightforward. I want to show you one more, which is very similar to this one. In fact, the first inequality is exactly the same. 5x plus 1 is less than 11. But on the second one, I'm going to change it to greater than or equal to. 3x minus 2 is greater than or equal to 10. Now, we've already solved both of these inequalities, so there's no need to redo that. The solution to the first one was x is less than 2. But the solution to the second one will now be x is greater than or equal to 4. And the solution that we're looking for is still the union of the individual solutions. So if we were to locate 2 and a 4 on a number line and draw each of their solution sets separately, the first one starts at negative infinity, stops at 2 with the parentheses, but the second one, because I turn the sign around, now starts at 4 and goes to the right, bracket on the 4. The union is what I get when I join these together. So if I were to draw them collectively in one color on the number line, we have 2 disjoint intervals. Disjoint meaning they do not overlap. And remember how to write the interval for a shaded portion of number line that is made up of 2 parts. You write the interval for each one, so negative infinity comma 2 with the parentheses, and bracket 4 comma infinity, and then to join them together as a single answer, you literally just put a union sign in between. So a compound inequality with OR is really simple, provided you can do 2 things. Number 1, solve a single inequality, and number 2, find the union of their solutions. Remember, union, you join them together. So write each interval on the number line using a single color. Your answer is everything that got colored in.